Welcome to Chapter 7, Section 6 Notes, Solving Logarithmic and Exponential Equations. Now the first thing we're going to do is go ahead and solve exponential equations, and then we'll go on to logarithms. For exponential equations, as long as the bases are the same, you can actually set the exponents equal to each other. So in part A, the bases are both 5, so we really just have 2x plus 4 equal to 5x minus 8, and that's a nice linear equation that we can just solve. Right, so let's move our x's to the right, we get 3x. Move the numbers to the left, so you add 8 and you get 12, which means that x equals 4. And that's it. Example B is actually a typo, so we're going to move on from that and go straight to example C. Now notice, 3 and 5 have nothing in common. There's no way you could rewrite 5. There's really nothing we can do here at all. So we're going to use a new strategy. And what that strategy is going to be to take the log of both sides. Now your log needs to match, the base needs to match the other base. So what I mean here is that 3 is a base, right? It's at the bottom of an exponent, which means we're going to put log base 3 on both sides. Now the reason we're using log base 3 is because log base 3 of 3 goes away. So you end up with x plus 3 equal to log base 3 of 5. And this is the equation we're actually solving. So we subtract 3 from both sides, and x equals log base 3 of 5 minus 3. And I'm going to leave it there for now. If you have a calculator, of course, you are always able to plug that in, maybe. Now, let's look at part D. 5 and 25. They actually both have something in common. They both have 5. Now, 1/5 is at the bottom, so what exponent would make it go to the top? That would make it negative. So we actually have 5 to the negative 1 to the 3x minus 2. We also have something that can make 25 5, and that is 5 squared. So it's the square root of 25x, which can be rewritten as 5 squared x, and then I'm also going to rewrite the square root. The square root can be rewritten as a 1/2 power. Well, now we're going to go ahead and multiply, because when you have a power raised to a power, they're multiplied. So we have 5 to the negative 3x plus 2 on the left, and 5 to the 2x times 1/2. Well, 2x times 1/2 is just x. Now we have the same base. Now those cancel, and we're left with negative 3x plus 2 equal to the x. And now we solve for x. So 2 equals 4x, and x equals 1/2. There's more. Let's look at E. Now for E, we have to first make sure that we get our base by itself. Okay, you always have to isolate the base first. On example C, they were already pretty much isolated, or the 3 was already isolated. So we're going to divide by 12. When we divide by 12, that actually simplifies to 125 over 3. Now, the way that we're going to get rid of E is the same way we got rid of 3 in part C. We're going to use the log. We're going to use log base 3. Well, log base 3 is the same thing as a natural log. So we're actually taking the natural log of both sides. That cancels, and 1 minus x equals the natural log of 125 over 3. Now we still have to get x by itself. So to do that, we would isolate x by adding 1 and then dividing by a negative, which means that x equals 1 minus the natural log of 125 over 3. And the last one for exponential functions, we're solving this equation, which is very similar to E. And again, we need to isolate our base. Our base is e to the x, so we need to add 14 to both sides first. 3e to the x is equal to 25. Divide by 3 e to the x equals 25 over 3. And then to get rid of e, you take the natural log again. And just like before, we took the natural log because the natural log of e is 1. So that's a brief overview of how you deal with exponential functions. Now let's look at logarithms. And what you really need to know is that to undo a logarithm, the opposite or the inverse of a logarithm is an exponential function. So let's look at part A. Now part A is not as simple. You could rewrite it, but we're not going to. We're going to use the base. And we only have one base here. It's based on log base 3. So our base is 3. So we're going to do this. We're going to have 3 squared and 3 to the log base 3. Now in class we talked about how when you have a base and they're the same, they cancel. So let's go away. 3 squared is 9. And we're left with 4x. So x is just 9 over 4. Of course, you always have to check, right? We have to check our answers. So when we check, we're plugging it back into the original equation. So you're asking yourself, does 2 equal log base 3 of 9 over 4 times 4? Well, 4 and 4 cancel. Log base 3 of 9 is 2, and 2 equals 2, so we're good. That is the answer. Another one, natural log. To get rid of a natural log, you'd use its base. Well, the base of a natural log is e. So we're going to have e here. Those both cancel, and you end up with x squared plus 3 equaling 4. Well, that's pretty simple. That means x squared equals 1, and x equals plus or minus 1. But we have to check. Now, if I plug in 1, I'm just going to do this out loud. 1 squared is 1, plus 3 is 4. That is the natural log of 4. Negative 1 squared is also 1, plus 3 is 4. So that works. And those are it. 3 more examples. Bear with me here. For log base 8, we again deal with our base. The base is 8, so we put 8 here. We put 8 here. Those cancel. And x squared minus 5 is whatever 8 to the 2/3 is. Well, that means we have the cube root of 8 squared. The cube root of 8 is 2. 2 squared is 4, so that equals 4. We add 5 to both sides. X squared makes 9, and x is plus or minus 3. Okay, and of course you would check it, but just so you know, they do both work. Now in part D, we have to do a little more work. The reason is because now we have addition and subtraction. But we have properties of logarithms that say that addition becomes multiplication. Because addition becomes multiplication, we're actually going to rewrite this side here, and condense it to the natural log of x times x plus 2. Well, x times x plus 2 is x squared plus 2x. And we want that to equal the natural log of x plus 6. Well, that means that the base for both of them are e, those cancel, and our actual problem is x squared plus 2x equals x plus 6. That's the equation we're solving. Now that is a quadratic equation, which means you need to move things around. So let's move everything to the left side. That gives us x squared plus x minus 6 equals 0. We factor that. Factors of negative 6 that add to 1 are positive 3 and negative 2, which means that x equals negative 3 and 2. Now we do have to keep in mind, I told you, right? We have to check this. But just so you know, here we have the natural log of x. You are not allowed to take the natural log, or any log for that matter, of a negative number. If you look at your function and you're graphing these things, if you look at the domain, x has to be bigger than 0. So which one of these, negative 3 or 2, makes it is less than 0? And that is negative 3. So that's not allowed. That's why we have to check. Okay. Last one. Same idea as the last one. Okay, we have log base 2 of x plus 5 minus log base 2 of x minus 2 equaling 3. Well, what this means is that we have to go ahead and combine the left side, condense it. Subtraction becomes division. So that becomes log base 2 of x plus 5 over x minus 2 equaling 3. We're going to use our base one more time. So we have 2 here and 2 here. Those cancel. So that x plus 5 over x minus 2 is 2 cubed, which is 8. Now we're going to use cross multiplication to go ahead and solve this. So I'm going to come over here. That means that we have x plus 5 times 1 equaling 8 times x minus 2. Distribute that, so x plus 5 equals 8x minus 16. Moving my x to the right, so we get 7x. Move 16 to the left, so we get 21, and x equals 3. One more time, you do need to make sure you check it. You can use your calculator for that, and it does work. Have a great day.